Welcome everyone to this seminar on building water's circular economy. We're really pleased that you're with us for the next hour for what should be a really interesting discussion. I'm going to start first by introducing myself and then introducing the panel, talking a little bit about this topic, and then we're going to go into some discussion, and then we'll have some time, probably about 15 minutes at the end, for questions. So firstly, without further ado, my name is Dan Walker-Nolan. I am the Director of Policy at Water UK. And for those of you who don't know who Water UK are, we are the trade association for water and sewage utilities throughout the UK. So that's England and the private companies, but also the mutual in Wales and the public companies in Scotland and Northern Ireland. And I will start by introducing the panel to my left.
Hello, good afternoon, everyone. I'm Pete Vale. I work for Severn Trent Water, one of the utilities that Dan's just referred to. I am Severn Trent's carbon and circular economy architect.
Hello, everyone. My name is Antonia Doncila. I'm Sustainability Manager for Climate and Nature at Openreach. For those who don't know, Openreach is not a water company. We build and maintain and service the largest broadband network across UK. But actually, we have a very special connection with the water sector through the technologies that we employ for telecommunications, which have many other additional uses, lots of circular opportunities to detect water leaks. So I'll be talking about that today.
Hello, everybody. Oh dear. My name is Megan Monkman. I am the Sustainable Energy and Water Officer for Tower Hamlets Council.
Thank you very much for those introductions. So just an intro from me, and anyone who's picked up a newspaper or indeed switched on the TV and looked at pictures from Parliament from the last few years will realise that the water sector is a sector that's under pressure. And it's under pressure for a number of reasons. And probably chief amongst them, or if not chief, then very high up the list, is issues of public water supply. So the Environment Agency predicts that by 2055, without any action, there'll be a 5 billion litre a day deficit between water supply and demand. Coupled with that, we've had drought. It won't have escaped your attention increasingly over recent years. So we had droughts leading to temporary use bans, so hosepipe bans as most people know them, in 2018, 2022 and 2025 in parts of the country. And, I suppose the bad news is that against that, we have per capita consumption in this country of water, which has basically flatlined since COVID. So we're at about 140 litres of water a day per person, where the government's ambition is more at 122 by the 2040s. And there's very little by way of water reuse. So the water that we do have generally is sort of potable water, and that's used for all different purposes. So we don't generally have water reuse for sort of rainwater recycling or grey water recycling. We use potable water for overwhelmingly non-potable tasks, so watering gardens, flushing toilets, etc., etc. So that's a situation where we are in a bit of trouble. But there is good news. And the good news is that there is massive investment that's going to happen over the next 15 years to increase public water supply. So you may have heard that £104 billion has been signed off in investment from Ofwat in a 5-year period between 2025 and 2030. That will deliver 10 new reservoirs, 9 large water transfer schemes, and a number of other water supply schemes. And there is a renewed focus at the moment in government because there is an upcoming clean water bill on things like water reuse, on water efficiency that stakeholders and the sector can use and seize on to try and make sure that this gap between supply and demand, this massive gap, gets reduced and gets closed. And there are also mechanisms at the moment to make sure that the current schemes being delivered by water companies to make sure that we have water supply are being driven through as quickly as possible, that planning barriers are being moved out of the way, regulatory barriers. And there are initiatives like the Water Delivery Task Force, which is a group which is run by DEFRA, can really lean in and make sure that these issues are being dealt with. So there is a massive challenge in water, but one that hopefully in time will be met. And we've got a great panel to speak about what's happening in the water sector and adjacent sectors on this issue. And I'm going to come to Megan first. And there's some really great stuff happening in Tower Hamlets with regard to water efficiency, water reuse. And if you could talk a little bit about that, that'd be great.
It would be my pleasure. Tower Hamlets have quite a few things going on in terms of water, more than I could possibly cover today. But I suppose a good place to start is all the way back in 2020, we put together our integrated water management plan. And, that covers all sorts of potential actions for the borough, and it particularly focused on the area of the Isle of Dogs, including things like surface water sewers, different water reuse schemes, this, that, and the other. But one of the issues that we come up against when looking at all of these amazing solutions and technologies that we could implement to make sure that we are recycling our water, making the best use of the very limited water resource that we have in the borough, is financing and it is funding. And so one of the schemes that we're currently developing at the moment, and we are currently trying to get through our local plan, is a water offset. So what we're looking at is kind of setting stricter requirements, because Tower Hamlets is such a water scarce area and an area at such high risk of flooding. We're looking at setting two very specific, stricter than national requirements. One is reducing that kind of, when a developer wants to build a new major development, requiring 80 litres per person per day from a design perspective. And when we're thinking about flooding, it's requiring that any major developments and any developments in a critical drainage area are being designed to have greenfield runoff rates from the offset. So not just if you're in a critical drainage area. And the idea behind this is if a developer can prove that there are credible site constraints that prevent them from being able to deliver these stricter requirements, they can pay a water offset, and then we can ring-fence that money and use that to deliver sustainable drainage systems throughout the borough. Rainwater recycling, grey water recycling through our council buildings, our library. I mean, our town hall already has rainwater harvesting and grey water recycling. And that was a huge project just to fund and put together for one building, but we've got so many buildings and so many council assets that we could do that if we can generate some revenue. But that's a little taster of some of the stuff we're trying to do around financing water.
Yeah, that's amazing. I mean, 80 litres per person per day, for those of you who aren't read in, is stellar. So that compares very favourably with the best water efficiency fit countries in the world. So that is a really, really amazing thing if it can be achieved. Antonia, I'll come to you next. And people wouldn't necessarily expect Openreach to be speaking at an event about water, given that you are mainly a telecoms company. So what are you doing here, and what sort of technology do you have that you think could help?
To be honest, we wouldn't have expected to speak on this panel probably a little bit over a year ago. Maybe we could have talked about cross-sector collaborations around flooding and kind of extreme weather events in the context of water, but not really circularity of water. But here we are today, and there's a lot of excitement. So it's something that us in the sustainability team at Openreach is the joy of our world. Fiber sensing. So Openreach is actively deploying the biggest network, fiber optic broadband network in UK. We build at a pace of around reaching 1 million premises per quarter. And we're very close to reaching a total of 25 million premises with fiber optic broadband. So that is, of course, to support the digitalization of the country, to meet all the data needs, all the devices that everyone has in their phone, which are very data hungry, and to develop a network that is resilient to flooding, a network that is resilient to the changing conditions. The beauty of this fiber optic broadband network, which, by the way, we have built almost over 200 million kilometers of fiber optic cables. They don't use light just to transmit data, but they can also pick up a lot of environmental signals. So they are the fiber optic is a fantastic environmental monitoring system, live, very granular. It provides insights to a really granular level of the environment around you. So how it works exactly, the technology we're using to detect water leaks, because that's what I'm here to talk about today, is called distributed acoustic sensing. So we have a lot of spare fiber in our network. We build extra just, again, to meet those future demands. But the spare fiber, which is currently not used, the good thing about it is that it's built alongside the pre-existing infrastructure systems. So there's a lot of overlap of where water pipes are and where fiber optic cables are. And this fiber, you can attach a little unit called an interrogator unit to it, and that will send pulses of light through that fiber, and then it will record back any disturbances in the disturbances in the light signal created by vibrations around it. So if there's a water leak, that will create an acoustic signal that will vibrate the way the light is transmitted through that fiber optic, and then that signal is picked up. You can pick up a signal, so from where you put your interrogator unit, you can pick up a signal all the way to 50 up to 100 kilometers within an accuracy of 10 meters. So from where you got the signal, 10 meters around it if there is a water leak. You can detect water leaks as small as 0.3 cubic meters per hour. So very, very incipient water leaks with great accuracy. And the key to this is once you have picked up that signal, you go and you check out what has created the signal. So you then understand the shape of the signal is created by a very specific event. You log that into your catalog, your library of sounds, and then you can use that again and again to recognize very similar signals in the future. So as long as we capture the signal, we calibrate it, you have done that in initial work, then it's very easy once you see a similar signal in the future to know that you know what to correlate it with. We've done a pilot with Affinity Water and with a fiber sensing provider, because at Openreach we provide the network. We provide the existing fiber optic network in the ground, and then we work with the fiber sensing providers who put those interrogating units and collect the data and put it in the library, the library of sounds. So we work together with the fiber sensing provider and with Affinity Water to put this technology to test and to detect water leaks, because there's so much water being leaked in UK. Around 19% of the mains water which has been treated, which there's a lot of CO2 emissions associated with sourcing this water, pumping this water, cleaning this water, distributing it. 19% of this water is lost. Around 3 billion liters of water a day are leaked, lost in the system before they reach your tap. That's the equivalent of 12,000 Olympic-sized swimming pools every day, equivalent of 400 million pounds a year across UK in cost. So the trial we've done, we have worked with Affinity Water and covered 650 kilometers of their network with the fiber sensing capability. And over 3 months' time, we have identified over 100 leaks early on in the process, which meant we have avoided 2.8 million liters of water per day from being leaked. So that's the equivalent of up to 15,000 people using their kind of average amount of water per day. Fabulous carbon savings, carbon emission savings, because again, you get in there early, there's less damage, less traffic disruption, because you have to bring in the big, like, heavy machines to dig up. There's less infrastructure damage, less kind of insurance claims, and the success of this pilot has been much greater than we expected it. And the beauty of it is that once we have demonstrated this works, because we have fiber everywhere across the country, from the cities to the villages to the remote islands, it means we can detect water leaks all across UK. With the signals we have gathered in our library of sounds, we can apply those same learnings and that same data to detecting wastewater leaks as well. So it's not just protecting a valuable resource, but it's also prevention against pollution. So, yeah.
That is tremendously impressive. I do feel compelled to say that leakage is at its lowest ever level at the moment, but water companies have very, very stretching targets, as you all know, and they do need to meet those targets. So having great new innovations and technologies in order to do that, I think, is absolutely fantastic. And it sounds like Openreach, having not been even a player in the market a year ago, has a fantastic proposition, so kudos. Pete, I'll come on to you now. And Severn Trent is doing some really, really great stuff on the circular economy, in particular on resource recovery. But one thing I wanted to zero in on in particular was the building and the operation of the world's first ever carbon neutral wastewater treatment plant. And I just wanted to get a little sense from you about how that operates, how you got to it, and what it means for the company.
Brilliant. Thank you. Thanks, Dan. And I shall absolutely get onto that very soon. But I just thought I'd tie the threads together a little bit from the discussion we've had today, because I think Dan framed brilliantly the sort of some of the challenges we face in water. And I agree that perhaps there's nothing more fundamental than ensuring there's enough water for us all to drink. But we've got to do that smartly and sustainably and affordably. And I think, we've talked about, or my fellow panelists have covered fantastically, two of the very sensible steps that we need to take, which is reducing the amount we all drink, so this per capita consumption, down to more sustainable levels, and reducing the amount we waste or leaks from our pipes. So those two things are fundamental building blocks or columns. A third, and this is the link to our net zero hub and our plans for biorefineries, is to get much better at water reuse. So extract less from the environment by reusing what is a waste, but is a really valuable resource that can be recovered, recycled. So to talk in a bit more detail about our net zero hub. So we have a large urban wastewater treatment works called Strongford, which serves the city of Stoke-on-Trent. And about 3 or 4 years ago, we took the decision to convert or upgrade that to our net zero hub. Because as well as sustainable water treatment, water supply, we also need to face into the challenge of the climate emergency. And of course, on a day like today, that is such a stark reminder, isn't it, of the need to address these big societal challenges in a joined-up fashion. So that's all about demonstrating at scale. So we have other facilities that are more like test beds, living labs, if you like, that we use to develop the technology and approaches that allows a more sustainable circular operation. And then the Strongford Net Zero Hub is about saying, wow, we're now confident that it's feasible, viable, desirable to do this. So we're going to make sure that this approach scales. And we'll choose this Net Zero Hub to build this at the full industrial scale, test that the different approaches, technologies work together, and then allow that to be effectively a blueprint, and not just for Severn Trent, but for the sector to say, if you and not all those technologies that are on the Net Zero Hub, and I'll talk a little bit about them, will be relevant for all our assets, but it gives us a bit of a playbook to say, we can deal with process emissions, these greenhouse gas emissions that are a major contributor to our carbon footprint, and we can look at how do we best recover resource, be that energy, and we've been doing that in the water industry for a very long time. We are one of the major generators of green electricity and green gas in the UK, and we'll absolutely continue doing that. But there are other opportunities of generating hydrogen, for example. Then there's materials. So some of the technologies that we've got at Strongford, the Net Zero Hub, look to recover cellulose from sewage. And that might sound a bit odd. It still does to me in a way, but that cellulose is from toilet paper. But cellulose is a really valuable resource and is used in the chemical industry. It's used to make construction materials, so we can capture that those cellulose fibres, clean it up, and then reuse it in sustainable materials. Ammonia is perhaps an even better example, actually. So ammonia is toxic to the aquatic environment, so we have to treat it, remove it from wastewater before we discharge to the environment. But of course, it's also an absolutely fundamental resource. Without it, we can't feed the world. We can't grow crops. And of course, nearly all that ammonia is produced synthetically using huge amounts of fossil fuels, shipped through the Strait of Hormuz. So let's forget about maybe the geopolitical aspect to it at the moment. But there's a massive opportunity to recover green ammonia from wastewater treatment plants. So we've got an ammonia recovery plant. And the other really nice circular thing about that is if you recover rather than treat, you potentially save energy, but you also don't produce nitrous oxide, which is 265 times as potent as CO2 at global warming. So energy, materials, and then a third, perhaps most important of all, of course, to go back to the water resource conversation, is the water itself. So we clean wastewater up to a very high standard to discharge to the environment, and actually the additional steps required to be able to reuse that water directly, or indirectly for that matter, are fairly small. So we are investigating now water reuse, and that could be all the way to direct potable reuse. So there are other parts of the world, Singapore, California, that already do this. So if you're going to, because we've got environmental drivers that require us to treat wastewater, quite rightly, to higher and higher standards, rather than discharge that very high quality water into the rivers, should we be looking at using it maybe for industrial applications, for agriculture? Could leave the nutrients in, and there's a nice circular approach called fertigation, where you use the water, but you also use the ammonia and the phosphorus that's in the wastewater. Or, you upgrade it to potable use. Dan touched on some of these strategic resource options. So these are sort of water transfer options from areas in the UK where perhaps water is a bit more plentiful to down in the southeast where we're facing the most severe water stress. And one of our schemes is to take the effluent from Minworth wastewater treatment plant, which is our largest, treat it to a very high standard, put it into the Grand Union Canal, and then it can be abstracted down in the southeast, treated again, and put into water supply. So I hope that gives you a sort of a flavour of some of the things we're looking at.
Thank you very much, Peter. That was really interesting. I mean, I might actually do a bit of audience participation at this point. It's probably a little bit early in the agenda, but no microphones necessary. So you've heard from Peter there about the idea of direct potable reuse. So that's cleaning wastewater to the extent that it can just be injected back into the grid and essentially used as drinking water. Can I just see a show of hands for people who think that they would find that acceptable? Yeah. Okay, I think that's a little bit over what you'd expect the average to be throughout the UK. Pete, do you have any initial sort of reactions based on what your customers have said about that? Because obviously in other countries, you mentioned Singapore in particular, there's been a real journey there, hasn't there?
Absolutely. And firstly, really encouraging to see. So I'm delighted to be speaking to an enlightened audience because, but it is understandable, isn't there, that there is a yuck factor. I mean, let's be honest about it. until I think you've had the sort of, a bit of, you have some knowledge or the processes that have been explained to you, it does seem quite a big leap to take sewage and turn it into drinking water. The technology's been around forever, really, about how to do it. You can use membranes, things called reverse osmosis, and effectively produce pure water from pretty much any dirty water source if you've got the right pre-treatment steps, but it might be very energy intensive and chemical intensive. So to Dan's point, it's the barrier really is public perception, and I think giving confidence to our customers that this is a safe, sustainable approach. And I think there is still a split, if I'm being honest. There are those who absolutely get it, and not only get it, but really would welcome it, and I guess have the same, those people who are very invested in trying to do what they can to deal with some of, the phrase I used earlier, society's big challenges, and there is a growing group of our customers who push us actually quite hard, and actually at this, touching on the financing, we've also got a very strong investor base who also really push us in that area. Investing in sustainable approaches is something that they are, the reason they're investing in the first place. These ESG investors, environmental, social governance investors. I think there's still quite a lot of work to do more generally. And whether we sort of move cautiously to an indirect potable reuse, because I suppose the other way of framing this is you could argue that we already do water reuse. We treat effluent to a high standard, it goes into the rivers, and then a couple of miles downstream we abstract it, treat it, and put it into water supply. So it's not actually that different, you could argue. But maybe there's a middle ground, and our customers may be more. So the Grand Union Canal approach that I talked about, or potentially in putting treated wastewater into aquifers and then abstracting it. So there's an additional barrier. I think that would have widespread support, and I think probably in a fairly short time frame, direct potable reuse will become more and more accepted.
Excellent. Thank you very much. That was a great answer. I'm going to move on now to, unless anyone else is interested in talking about that particular, okay?
If I can add just very briefly with my OpenReach cap on, I think, it's a fantastic opportunity to reframe the conversation and remind everyone that all water is part of this big natural cycle, and ultimately what you call fresh water, from the stream has gone through a evaporation, condensation cycle, and ultimately what we're doing here in recycling water is not very different from that. So helping people reconnect with that reality and very much using a digital infrastructure, sensing capabilities to show how these systems work, how they mimic what you see in nature, can help build trust and show that we're working with the natural systems, not against them.
Perfect, thank you. I'm going to do a few quick-fire questions now, and hopefully everyone's thinking about their questions that they're going to ask us, because we'll come to those in about 10 minutes. I mentioned earlier that there is a clean water bill that is due to be debated in Parliament. It hasn't been introduced yet, but probably later this year or early next year. And I'd like to invite the panel to discuss the one thing that they want to see in that bill that will encourage water reuse or water efficiency or this circular economy idea. And Megan, I'd like to come to you first.
I think if we're thinking about policy and we're thinking about the kinds of policy we need to change, I think the number one thing that comes to my mind immediately would be we need water companies to be able to supply non-potable water. So we have in our local plan that we're requiring new developments to install dual piping, so that if hypothetically one day a wonderful water company could say, here's some recycled water we made, would you like it? A building can then use it and immediately have it into the plumbing instead of having this huge additional cost in the future of retrofitting all of these buildings. But at the moment, even if we have buildings with dual piping, water companies legally have to provide drinking quality water, even for things like flushing toilets, which don't need it. You know, I'm not drinking from my toilet, I don't know who else is, but I don't need that high quality water going into that kind of system. So we've got to think about the grades and qualities of what we're using water for where, and I think that's a huge limitation on water companies. That would be my one wish. I've got many, many other wishes, but that would be the number one.
Okay, if we've got time, we can get to another one of those maybe. And Antonia?
Biggest priority from the Clean Water Bill for us? Well, working with water companies in these trials, we've seen that we can easily scale up these solutions to save even, to prevent even more water leaks. And we've seen a great growing excitement from water companies to adopt this. However, there are some limitations, and I think that's where the Clean Water Bill can help with, by introducing greater flexibility to enable water companies to adopt innovation mid-cycle. So water companies operate on a 5-year cycles, funding cycles, regulatory cycles, and if you happen to find a solution which everyone agrees is it delivers the performance required, bringing that from pilot to large scale sometimes can be difficult, simply because of when you happen to pilot that solution, and if it's mid-cycle, then there's very little you can do to invest further. So what we've seen with water companies, it's kind of a lot of attempts to navigate a really complex situation rather than reluctance to scale up with this innovation.
Yeah, I mean, that's an excellent point. And actually, in electricity networks, there is much more expenditure outside of periods, and there is much more flexibility outside of those price control periods to invest. So I think that's a really great shout. Peter?
Yes, thank you. Yes, I guess to a degree I'm copying my Antonia and Megan here, but for me it's about getting the regulatory model right to really help stimulate innovation, but more importantly, being able to implement and deploy that. And absolutely there needs to be the right checks and balances and controls, because we're talking about water here, so, you know, obviously safety is non-negotiable, but let me try and, I suppose, context and explain where some of the sort of hurdles at the moment are. So, you know, if we wanted to trial, less about trialing, more about implementation. So it's not straightforward, but it's relatively straightforward. I talked about the Net Zero Hub, to trial stuff. It's much more complex than to turn that into business as usual and install it at full scale, because there is getting the sort of the permitting side of it sorted, so we're able to operate stuff that hasn't been operated yet in the UK, might have been operated in other parts of the world. So that's a challenge that we're really facing into the moment. How do we effectively deploy the innovation that we've tested and have deemed, you know, ready to go, it's viable, it's economically viable, it's desirable. That last step, the sort of getting the regulation right to put it in, is difficult. And then with sort of resource recovery in particular, it's easier with energy, but with material and water, you know, getting the regulation around end of waste sorted. So to make it, I suppose, more streamlined, so you can more collaborative, so we can all work together, because we've all got. I'm highly confident we all want the same outcome at the end. We're just approaching it in a rather disjointed fashion at the moment. So how do we, as policymakers, regulators, water companies, just work more closely together to achieve what I think we all want?
Yeah, that's a great concept. I mean, one other quick fire question that's come into my head. So the government has an enormous housing target. I mean, so there is this massive gap between supply and demand that we think might come down the track without massive action. that is taking place. But also, we've got 1.5 million homes that the government would like to build in this Parliament. And the unfortunate fact of the matter is that if you look at water company water resource management plans, they haven't actually planned for those targets at the moment. So there is likely to be potentially a bit of a crunch at some point between having enough water for the homes and the economic ambitions of the government. I suppose in light of that, and I'm going to come to Megan first, and it's a little bit of an unfair question, but do you think there are sufficient incentives for local authorities and water companies to work together on sorting out some of those issues?
I mean, I think local authorities and water companies are already working together to solve those issues, but I do think it is difficult. I would also say, I come at this from a Thames Water perspective, and Thames Water's plan theoretically will bridge the gap and bridge the deficit, but a huge, huge, huge portion of that plan is based on the assumption that demand will be reduced, with very vague statements to the ether of how that will happen. So there's this very high risk that, we're planning for our water future on an assumption that everybody is going to change their behavior, and I don't know that's happening. From a local authority perspective, sometimes I think local authorities have more power than they do. We can affect planning, and that's one of the reasons we're setting really tight standards. But we can also, we are one of the main sources of information for our residents. We protect our most vulnerable residents. When there is an issue like drought, we're going to be the ones looking to quickly help do disaster relief, as well as Thames Water. But we do have a close relationship, but it is very difficult. Could you remind me exactly what the question was again?
Is there anything, I suppose, that if you do it legislative-wise or even just through signalling, anything that you would do to compel water companies and local authorities to work more closely together, on a sort of a more day-to-day basis? So you talk about demand management and some Thames's plans you have doubts about. Is there a dialogue about that? Do you account for that in your local plan, for example?
There is dialogue about it with Thames Water, but I think you've also got to, taking it away from all the high level, like if you just imagine you're a local government officer, you're speaking with one Thames Water employee. That does not represent all of Thames Water, nor the strategic decision-making Thames Water will have. I think the new water regulator is going to bring in some of those requirements. We're going to have much more regional and strategic planning, which is great. But even then, on a local authority level, I as an individual, not as a representative of government, I do think it is very difficult when you are working with a water provider whose main motivation is still profit at the end of the day. We're a local government. Our main priority is always going to be residents and making sure that our residents have everything they need in the borough or whatever municipality or kind of district you live in. I think when we're looking at how do we make sure with all of these huge housing targets that we have, and Tower Hamlets have some very, very large targets, it can get very theoretical and very conceptual. I think that, yes, water companies should be required to work with their local authorities. I don't know what's going to be in the new plan that the government publish. They're going out for consultation now, so also if you in the audience have ideas about what you think should be happening in these arguments, go on and log into your consultation platforms and get involved. I think there is action from the local authority that needs to happen on engaging with our residents and communicating some of this. We've had issues as a local authority where residents won't get water and immediately in their minds it's Thames Water's fault. And it's not sometimes. Sometimes it's their building management's fault. Sometimes it is a leak that's beyond Thames Water's boundary. Sometimes it's the local authority that should be taking control, but it can be very unclear. And if you're just a day-to-day person, you're not going to be researching whose statutory responsibility is what and who should I go to fix X problem. So yes, I think that there should be requirements for Thames Water and all water companies to work with local authorities. But I do think more clear guidance on whose responsibility is what from the new legislation will be very, very useful. I think enacting Schedule 3 so that we know who should be delivering sustainable drainage systems, which will also help with, managing our sewers and making sure that we've not got too much, and funding local authorities effectively to be able to manage this. In some local authorities, you only have one person in a team that has to handle all of that for all of their residents, and it's not possible. So I think there's lots of making it more efficient, yes. Bringing in more regulation, yes. But it's not just about more, it's about, like, as you said, effective regulation. That was a very rambly answer. I'm very sorry. I went in all sorts of places there.
It was great. A good shout out for regional planning as well, which is something that I think water companies have very, very high hopes for because of the polluter pays principle and making sure that everyone who's responsible for pollution in particular is cleaning up the issues that it creates. So everyone's had about 40 minutes now of discussion from the stage. Hopefully you've had a good old think about what you might want to ask us. So I'm going to throw out to the audience if there are any questions, anything on anyone's mind that you'd like to ask. Oh, yeah, we've got 2 hands up, so I'll go to this gentleman here and then to this lady there.
Hello, you talked about supplying non-potable water, and I just wanted to get an idea from the water companies that does supplying non-potable water for domestic applications actually make financial sense? Does it make financial sense to have 2 sets of piping going to lots of houses versus the extra cost of treating water up to a potable standard?
Excellent question. Yeah, Peter.
Yeah, very, very good question. And I think you highlight an important point. Dual pipe is very expensive. And it's not actually just the economics. It's also the health and safety aspect of it too. So if you've got, because in California, for example, they did do this for quite a while, purple pipe. So you'd have the second purple pipe that was non-potable. But if you can imagine in your house you had 2 pipes, you might unknowingly connect into the wrong one. So my personal view is that dual pipe isn't the way to go, because I think you're right in that the costs are prohibitive to lay 2 pipes, which doesn't offset the savings in treatment. And so my personal view is that water reuse and supplying non-potable water is absolutely the right thing to do, but maybe you're supplying water to agriculture, or you're supplying it to industry, you're supplying it to data centers, rather than 2 pipes in a domestic setting. But it is done, and there is some success with it. So, as I say, that's my view, but yeah.
I'd also just like to add, I think you really need to think about what kind of development you're talking about. If you are talking about a detached house where you are the sole landowner and you are responsible for the piping and you have control over that, then that is a real risk. If you're looking at a high-rise building with multiple flats, with building management teams and facility management teams who are taking on that responsibility, it's a very, very different picture. And also when you're thinking about the kind of density we have in London, so I do agree in some areas it may not be the correct solution. I think it's about looking, and we've also, to answer your question about costs, we've had a look at kind of what the costs of dual piping would be not from the water company's side, but from the kind of development side, and it's a minimal cost compared to the rest of the building. So having the capability to connect to those systems, would they one day exist, shouldn't majorly affect the viability of development. So I think it really depends famously, as the internet says, it depends. But, yeah.
That is excellent debate. I suppose it depends what the counterfactual is, doesn't it? Basically, if it's the counterfactual is no water at all, then I suppose that it isn't that expensive, maybe. We've got a question over there. Sorry, jumping about a bit.
Thank you. I was wondering, with the whole idea of kind of reuse of our own kind of water, drinking our own kind of wastewater, etc., what's the implication? It's fair enough when it's just kind of human waste, if you like. I can imagine that's treatable. But obviously into your sewage treatment works, it's not just that. It's some industrial waste as well, and whatever else goes down our kitchen sinks and whatever. How does that work? Is it treatable to that level, or do we find in Singapore and California that they've got particular controls on what actually goes into that system to start with?
Peter, I'll throw that to you, if that's okay.
Yeah, of course, an absolutely brilliant question again. And first off, I should say that source control would if we could crack that nut, that would be brilliant to stop things like PFAS, pharmaceuticals getting into the wastewater system in the first place would be massively helpful and much more cost-effective doing it at source than trying to treat it end of pipe. But to answer the question, it is treatable. Absolutely, the technology exists, but it does add significant cost. So to give you a sort of a bit of, I suppose, colour around that, the EU Urban Wastewater Treatment Directive, the sort of review of that, they're talking now about quaternary treatment. So there'll be a dedicated fourth stage of wastewater treatment to specifically target things like pharmaceuticals. And of course, pharmaceuticals are a good example of, it's not just trade waste we're talking about here. All of us are excreting, if we're using pharmaceuticals, excreting pharmaceuticals into the waste. So yeah, you can't solve the issue just by, really tight controls on industrial trade waste, although that is a significant part of the picture. But yeah, the technology exists, but then you've got to think about the consequences of investing in potentially energy-intensive processes, chemically intensive processes, that if we take PFAS, we can use things like granular activated carbon to remove it, but then we've got to make sure that we destroy it, right? Because if we're not careful, the PFAS will just be circulated in the environment. So you've got to then make sure your destruction of your adsorbent, if you like, is effective. So in short, you can do it, but yeah, you're right to point out that does require careful consideration.
Yeah, absolutely. It's an excellent question. Do we have any other questions? Yeah, lady at the front.
Hi, so Peter, I know you mentioned for water reuse that reverse osmosis it's a good measure to use, but it's got a high energy requirement. Where do you see wastewater reuse? Like what technology or what kind of direction do you see is where it's going towards?
Yeah, thank you. So yeah, reverse osmosis, if you like, is the best barrier in that the membrane has the smallest holes, to put it simply. So has been used sort of as the sort of standard, I suppose, approach of treating to potable standard, albeit actually you take too much out, so you have to add salts and things back in to make it palatable. But that aside, but there's been huge advances in membrane technology over the years. So reverse osmosis itself is more energy efficient, and ceramic membranes are perhaps where the focus is at the moment, and maybe nanofiltration rather than full RO. But so a lot of the cost with RO isn't in the RO itself, it's in the pre-treatment. So what I'm working on, and I think where we need to head, is thinking about what is the most sustainable way of doing this. And there are actually approaches on the wastewater treatment side where you might deploy a membrane because it helps on your wastewater treatment process, helps drive the carbon down, and that actually acts then as a really good pre-treatment step that then just allows you to put on that final RO polishing step, or maybe ceramic membranes and nanofiltration to get to, and disinfection, of course, to get to potable standard. So yeah, it's an area that's rapidly developing.
Wow, this is getting into the detail really, really quickly. I think have we got another? Yeah, we've got another two questions. So the gentleman here, and then the lady over there. And actually, if you don't mind saying what organisation you're from before you ask a question, that would be great, and just your name.
Yeah, it's Andy Duff from Consulting.
We can't hear you. Sorry, Andy.
Change it.
Yeah. Thanks, Peter. We can share our.
So it's
I'm so sorry.
Andy Duff from Swallowtail Consulting, and you mentioned agriculture a couple of times, and my understanding is the actual amount of water the agriculture industry uses is pretty minimal. So, but you also mentioned something, I think it was called fertigation or something, was it? And I was really interested just to understand a little bit more about that. It was about reusing ammonia and phosphorus as well.
Sorry. So you make a good point. I think there are other parts of the world where the agricultural use of recovered water, the size of the prize is bigger because, as you rightly point out, in the UK it's significant, but it would help in terms of abstracting less from the environment. So I do think there's a place for it in the UK, but yeah, in other parts of the world there's an even stronger driver. And fertigation, is really interesting. There's two approaches really. So there's ammonia and phosphorus in wastewater. Both are valuable nutrients, of course, required for plant growth. And we spend a lot of energy and chemical taking them out. You can either recover them as, ammonium hydroxide, say, and something called struvite, which is a slow-release phosphorus fertilizer, and then apply that to agriculture and the water separately. Or an approach that is used in other parts of the world, leave it in, but, put it through a membrane, make sure you've taken out any sort of, viruses, so that it's safe to apply to agriculture, so you've got clean water with the ammonia and phosphorus left in. And that, I think, is a really neat way of doing it, a really sort of sustainable approach.
Excellent, thank you very much. We've got a pizza-heavy list of questions, so maybe this is a question, the next one that Megan and Antonia will have a view on. Should we, yes, another question in the front, I think.
Thank you. Hi, sorry, this might be another Peter one, sorry. I'm Olivia Bertham from Deloitte. Quite interested in whether there's been any experiment, it might be the others as well actually, I would be interested if this is an urban solution as well, around black soldier flies and the use of waste in that. And I know obviously in the food waste, it's really innovating now and scaling. Very interesting work being done there. I guess there's some challenges with sewage sludge and black soldier flies in terms of what you can use this black soldier fly larva for in terms of a feedstock. But has there been any have you tried anything around that? Is that part of your innovation hub? But also, is that something, I don't know whether that is something in Tower Hamlets that you've seen at all in terms of a waste solution, if you like.
Black soldier flies.
Yeah, so black soldier, it's fascinating actually. Yeah, they're like the fastest growing protein source, and they eat just about anything. So food waste, we're seeing it now innovating for supermarket food waste. So you can feed it just about anything, and within a week you've got a larvae that is very high quality food that currently goes to animal feed. I happen to feed my dog on it, to be honest. He has little insect pellets, basically. He doesn't love it, but he gets it because it's low carbon. But in terms of them being able for humans to eat the animals, that's where the kind of challenge is, I guess. But there is a problem with what we do with sewage sludge as well, isn't there? I mean, we spray it on the fields, but I think that can be very controversial. So I was just interested to know, like, at that end, in terms of the circular economy. I love the title, by the way, Circular Economy Architect. Great. I'm going to adopt that, I think. Has there been any tests and pilots in that? Lots of a very long question.
No. I share your enthusiasm, by the way, and I'll keep this brief because I don't want to monopolise the discussion. But I've talked to a couple of organisations that do black soldier fly harvesting, and it is potentially a beautiful circular approach, isn't it, to generate a protein source that certainly could be used for livestock or pet. I didn't know you could. Pet food was made from it, and I think with the right procedures in place, it could work with sewage sludge. And as I say, I've talked to people who are interested in doing a trial. I think Scottish Water might have done. They've certainly used insects, so I'll double check. But yeah, it is if we could get it to work, it would be a wonderful solution. I agree.
Yeah, and 3 words: sludge eating worms. You heard it here first. I've seen that in action. It's absolutely remarkable. Okay, well, we're nearly at the end of our time. So I wanted to give the panel just a kind of final word, really. And I suppose some of the conversation has been maybe a little bit gloomy. I started off a little bit gloomy. But there are reasons for optimism in the water circular economy. So I wanted to come to everyone with a sort of final optimistic message. Is there one innovation or one thing that you're particularly optimistic about that you think is going to turn the tide and make things a lot better for consumers, for the environment? And I'll come to Antonia first, if that's okay.
Surprise, surprise. I'll be talking about fiber sensing. But it really is a platform for cross-sector collaboration. It's something that it's non-invasive. It's a poster child of circular economy. It already serves a well-defined purpose in telecommunications, and then you can get across with the water company, with the energy companies, with every utility provider, with every company that has infrastructure in the ground, and use fiber as a platform to gather real-time intelligence on how all these infrastructures work, identify any vulnerabilities early on, real-time, act before it's too expensive, act before there's any damage, before any valuable resources are being wasted unnecessarily. And it provides irrefutable data that with minimal intervention, you have maximum benefit for the companies themselves in saving OPEX, and for the customers in maintaining that customer trust that the services they pay for will be reliable again and again.
Thank you. That was a very strong pitch. Megan.
Okay. This isn't going to sound optimistic at the start, but it ends up being optimistic, I promise. I think when we talk about this, it can be fun to get sucked into all of the innovations and technologies, and all of that is exciting, but the most effective thing we can do in this water scarcity world is to use less water as individuals. And I encourage all of you to start thinking about your own water consumption. It will be higher than you think. We are going to run out of water. We are. There are going to be a lot of deaths in this country because of the heat waves we're going to see. I don't know if you guys have been outside today. It's not pleasant, and this isn't even the hottest it's going to get this year. By 2050, we're looking at temperatures of 45 degrees. And think about how the country is surviving this, which is nowhere near. So this is not it's not an easy problem, but it is everybody's responsibility. And I think we need to focus on both. The water industry is doing its thing, and the circular economy, hopefully with new regulation, is going to be great, but that's not enough. It has to be all of us, and we all have to think about our own water consumption, our businesses' water consumption, how our businesses are handling water, what we're investing in, all of these big questions. Everything's related, everything's interconnected. The positive spin on this is that it's really fun, and when you get into these communities and you start to think about these solutions creatively, it can be silly. My housemates laugh at me for washing my hair in a bowl, because they think it's a bit extreme, but I live in Cambridge, and Cambridge is incredibly water scarce. And, I think getting creative, building community around this, and kind of getting involved can be very, really, really fun. And I think it is going to be that hyper-local community kind of level that we should all be digging our fingers in. That's going to be the optimistic spin. But if we don't, that's going to be a fun thing to live through, I'm sure.
Okay, well, that's a very, very big challenge to everyone. So hopefully everyone's on notice. We are all people that need to have our agency and play our part. Peter, would you like to give us a final word?
Yes, thank you. And I don't disagree with anything you've said. I think that sort of personal responsibility and thinking about water footprint as well as a carbon footprint isn't a bad place to start. But looking at it from, I suppose, a water company perspective and turning a challenge into a massive opportunity, I genuinely believe that in the next 5 to 10 years, we're going to move away from wastewater treatment plants that are these things that are tucked out of sight and, do a good job treating the wastewater, to this biorefinery resource recovery factory concept. And it's probably not widely known at the moment, but we already export, I think in my intro, green gas, green electricity, but just widening that concept to get water, materials and energy out of the wastewater and deliver real sort of social value from a wastewater treatment plant is what that's what keeps me sort of really interested in the work that I do, and I'm passionate that we'll go about and achieve it.
Well, I don't think I can top the words social value and wastewater treatment in the same sentence, so I'm going to leave it there. I'm going to ask everyone in a minute to thank the panel in the traditional way, but I'd also like to thank you first for coming along today, for taking part, for listening, and I hope you all a great rest of your conference. But can you all thank the panel?